Have you ever wondered how your smartphone manages to send a message almost instantly, or how large corporations streamline their operations? In our interconnected world, understanding the backbone of communication and functionality within systems is more crucial than ever. Whether it's the swift exchange of data between devices or the seamless operations of a multinational company, the principles governing these processes are deeply rooted in communication and functional models. Today, we'll explore a variety of these models that not only illustrate how information is exchanged, but also how systems are structured to perform efficiently and effectively. We'll look at the sender-receiver and Shannon-Weaver models, which lay the foundation for basic and complex communications. Additionally, we'll delve into the transactional and network models, essential for understanding dynamic interactions and data transmission in networks. On the functional side, we'll introduce models like functional decomposition and data flow, which help break down and map out the operations within systems. We'll also touch on the entity relationship and functional flow, block diagrams vital for database design and system engineering. Stick around as we dive deeper into each model, revealing how they shape the digital and corporate worlds. Imagine you're sending a message. What's really going on? Let's delve into the sender-receiver model, a fundamental concept in communication. This model simplifies the communication process into two key roles: the sender and the receiver. The sender begins the process by encoding a thought or an idea into a message. This could be as simple as typing out an email or as complex as crafting a digital advertisement. Once the message is ready, it's sent to the receiver, who then decodes it to understand the sender's original intent. The effectiveness of this process hinges on how well the message is encoded and decoded. Misunderstandings can occur if the message isn't clear, or if the receiver interprets it differently than intended. This model isn't just theoretical, it's extremely practical. Consider how you interact with emails. The clarity of your written words directly affects how the recipient understands your message. As foundational as it may seem, this model is crucial for grasping the basics of communication. Now let's add a twist with some noise. Imagine a bustling cafe filled with chatter and clinking cups, a perfect setting to introduce the Shannon-Weaver model. Developed by Claude Shannon and Warren Weaver, this model outlines a communication process that includes an information source, a transmitter, a channel, a receiver, and a destination. The journey begins with the information source, which generates the message. This message is then encoded by the transmitter into a signal that can travel across the channel, the medium through which the message is sent. It's here, in the channel, that noise plays its part. Noise represents any interference that distorts the signal, making the message less clear to the receiver. Upon reaching the receiver, the signal is decoded back into the message and delivered to the intended destination. The beauty of this model lies in its ability to illustrate how noise impacts communication, helping us understand why sometimes, even in our high-tech world, messages don't always come through clearly. This model is particularly vital in optimizing communication technologies that operate under various interferences. Communication is not just about sending a message, it's about interaction. Imagine a conversation where both participants are not merely speakers and listeners, but are actively exchanging roles, constantly. This is the essence of the transactional model of communication. In this model, communication is seen as a dynamic and simultaneous process. Both parties are senders and receivers at the same time, influencing and being influenced by each other. This model is particularly useful in understanding complex interpersonal communications and customer relations. It acknowledges that context, such as social setting and individual backgrounds, plays a crucial role. Feedback loops are integral, allowing for adjustments and mutual understanding to be refined in real time. Noise, or interference in communication, is also considered, highlighting potential distortions in understanding. The transactional model is indispensable in environments where interaction is key to success. It helps us grasp the fluid, ongoing nature of communication, where meanings are continuously created and recreated. This dynamic model mirrors the fluidity and interactivity of modern communications. In a web of devices, how does data find its way? The network model in computer networks is a fascinating exploration of how data packets navigate through a complex infrastructure. Let's dive into some of the critical elements that make this possible. Firstly, protocols. These are sets of rules and standards that dictate how data should be transmitted and received. Protocols ensure that devices from different manufacturers can communicate effectively, making them the linchpins of network interoperability. Next, we have data packets. These are small chunks of data formatted according to protocols. Each packet contains not only the data but also metadata about its origin, destination, and the sequence in the overall message. This segmentation allows for efficient and reliable data transfer across networks. Then, there's routing. This process involves determining the optimal path for data packets to travel from source to destination. Routers, which perform this task, use algorithms to decide the best route based on network traffic, hardware limitations, and other factors. Addressing is another crucial component. It involves assigning a unique address to each device on the network, similar to a postal address, ensuring that data packets reach the correct destination. Understanding this model is crucial for IT professionals working with network infrastructure. Scene script. How does a large organization manage its myriad conversations? In the bustling world of corporate communication, understanding the flow of information is crucial. Several models help demystify this complex interaction, including the linear, interactional, and transactional models. Starting with the linear model, it's akin to a one-way street. Information travels in a straight line from the top management down to the employees. This model is simple and direct, but it often misses out on feedback loops that could offer valuable insights back to the top. The interactional model adds a layer to this communication by incorporating feedback. In this setup, messages flow back and forth, allowing for a more dynamic exchange of ideas. It's not just about sending out information, but also about listening and responding, which enhances understanding and cooperation. Then there's the transactional model, which views communication as a simultaneous process. Here, everyone involved is both a sender and a receiver, actively shaping the conversation. This model reflects the real-time complexity of human interactions and is pivotal in settings where immediate feedback is essential to the task at hand. Effective communication is the backbone of any successful organization, breaking down complex systems into simpler components. The functional decomposition model is a methodological powerhouse in the world of systems design and architecture. At its core, this model involves dissecting a complex system into smaller, more manageable modules or functions. This not only simplifies understanding, but also enhances the manageability of the system. Imagine a large enterprise software system. Using the functional decomposition model, this system would be broken down into distinct components like user interface, data processing, and data storage. Each of these components is then further divided until the system is a collection of simple, well-defined functions. This granular approach is crucial because it helps in pinpointing responsibilities, streamlining development, and improving maintenance practices. It allows designers to identify dependencies between different parts of the system, which is essential for both troubleshooting and scaling. Moreover, in software development, this model supports modular programming, where different teams can work on separate functions simultaneously, greatly improving development efficiency and reducing time to market. This model is a fundamental tool for system designers and engineers. Let's track the journey of data through a system. The data flow model is a powerful tool used to visualize and analyze how data moves within a system. It outlines the various processes that data undergoes, the interim data stores it resides in, and the external entities that interact with it. Imagine data as water flowing through a series of pipes and tanks, each process a pump that modifies or redirects the flow, and each store a reservoir holding the water temporarily. This model is particularly useful for spotting where data flow slows down or stops. These are what we call bottlenecks. By identifying these bottlenecks, systems analysts can work on solutions to enhance efficiency, ensuring that data does not just sit idle but moves smoothly and swiftly to its intended destinations. Moreover, the data flow model helps in optimizing processes. It allows analysts to redesign workflows, eliminate unnecessary data handling, and streamline operations to save time and resources. For systems analysts, this model is indispensable for designing efficient workflows. Every relationship matters, especially in databases. The Entity Relationship Model, often abbreviated as the ER model, is a conceptual tool used primarily in database design. It allows us to visualize the structure of a database in a clear and systematic way by defining the entities, which are objects or concepts that can have data stored about them, and the relationships, which are the connections between these entities. Entities are represented as rectangles and are the building blocks of the ER model. Each entity has attributes, the details that describe or identify it, shown as ovals connected to their respective entities. For example, in a database for a bookstore, the entity might be book, and its attributes could include title, author, and ISBN. Relationships depicted as diamonds illustrate how two entities share information in the database. These can be one-to-one, one-to-many, or many-to-many, depending on the nature of the connection. This model is crucial for anyone involved in building or managing databases. We've journeyed through a landscape of models that sculpt our digital and corporate worlds. Let's take a moment to recap the insights from each model and their impact on the realms of information technology and business. Starting with the sender-receiver model, we explored how communication involves encoding and decoding messages, forming the foundation for understanding interactions. The Shannon-Weaver model introduced us to the components of communication like channels and noise, crucial for grasping signal transmission in noisy environments. We then delved into the transactional model, which illuminated the dynamic nature of communication where feedback and context play pivotal roles. The network model showed us the intricacies of data transmission within computer networks, emphasizing protocols and routing. In organizational contexts, various communication models help decipher the complex flow of information across different levels and departments, enhancing clarity and coordination. Turning to functional models, the functional decomposition model breaks down systems into manageable parts, while the data flow model and the entity relationship model provide frameworks for understanding data processing and database design. Lastly, the functional flow block diagram maps out the operational flow, aiding in system analysis and project management. Mastering these models not only enhances operational efficiency, but also drives innovation in our interconnected world.